Very good morning, dear friends. Myself, Dr. Vikrant Sudhakar Palekar. I am working as Assistant Professor in Gokhale Education Society's Arts, Commerce and Science College, Jawahar, Palghar. Today, we are going to see a new topic, that is photochemistry, that is from the unit number 1. In earlier classes, and we have seen there are n number of reactions which are being carried out by supplying heat energy, in which the reactants are getting converted into products. In order to convert the reactant into the product, either we can use different catalyst which helps to reduce the energy content which is required for converting reactant into products. But in the photochemistry, this is a branch of chemistry in which the photochemical changes which are being carried out in order to convert the reactants into the products. Let us see what is basically the photochemistry. So, this is an organic reaction which is brought about by light radiation of suitable wavelength are called photochemical reactions or photoreaction. Basically, a light radiation is being used in order to carry out the reaction. The light source is being used, as we know that a light radiation which is maybe in the range of the wavelength in the ultraviolet or visible. So basically these are the reactions which are being carried out by using light source of suitable wavelength. What are the example? What are the natural process such as photosynthesis or vision mechanism, how we can see a particular object? So these are the examples of photochemical reaction. If we see in photochemical reactions, a wavelength used being around 200 to 300 nanometer, and we know that this is a range which is being in the region of visible and UV light. As we know that in order to carry out the reactions, basically what is the requirement, whatever the bonds present in the reactants need to be broken. So in order to break a covalent bond, we need a dissociation energy. So whatever the, in order to break the bond, we need an energy which is around this much. So this much energy is provided when you bombard or impact a light which is around in the 200 into 300 nanometer. So this much wavelength is sufficient in order to break the covalent bond. So this is the basis of the photochemical reaction. If we see the natural process which is being taken out in the nature, in which the plants carry out photosynthesis, in which carbon dioxide and water in presence of sunlight forms glucose. So this is a natural process. So this is being carried out with the help of sunlight. This is a very good examples of photochemical reaction. I hope so you have understood what is basically means of a photochemical reaction. This is nothing but the organic reactions which are brought about by light radiation of wavelength from the range of 200 to 300 nanometer. Okay. So basically if we see what is the difference between thermal reaction and photochemical reactions. So in case of the thermal reaction, these are the reactions which are initiated by supplying heat energy from outside. So these are called as the thermal reactions. We have seen number of reactions where heat is provided, let us say 200 degrees Celsius, 50 degrees Celsius, minus 40 degrees Celsius. So heat energy is provided. So basically when we see in those reactions, thermal reaction, what is basically change is takes place, either heat is absorbed or heat is evolved. On the basis of that, we used to categorize the reaction, that is exothermic reaction or endothermic reaction. So basically this is a thing which is being happening in case of the thermal reactions, and which are taking place in absence of light. So in thermal reaction, what is the main important thing? Heat energy being provided. So in case of the photochemical reaction, what is the requirement? In order to carry out the photochemical reaction, you must have the presence of chromophore in the reactants. Chromophore is nothing but the functionality which is able to absorb the light energy. Okay, so that is must in your reactants. So chromophoric group is must. Photoreactions are highly specific in terms of cleavage of a particular bond depending upon energy absorbed. In photochemical reaction, whatever the light energy we are going to supply, only particular bonds are going to cleave or break after absorbing that energy. So we can say many bonds can be cleaved photochemically. Photochemically we can cleave many bonds at a one particular time. So this is a basic things we need to remember in case of the photochemical reaction and thermal reaction. So basically when we say whenever particular photochemical reaction takes place, so it is taking place in terms of by absorbing a light. Basically what is meant by light? It is the source of electromagnetic radiation. Okay, so this particular electromagnetic radiation we know that is nothing but the photon. Photon is nothing but quanta or a packet of light which is being incident on the your organic reactants. So remember, light contains energy equal to one photon. And what is meant by photon? It is the smallest amount of light carrying energy, okay, which is equal to h nu. So we have to remember when one particle of chemical substance can absorb only one photon from a light beam. We have to remember one small substance can absorb one photon. One particle can absorb one photon energy, and that is equal to delta E is equal to h nu. So this is the equation we know that this is the equation given by Einstein. So we have to remember what is meant by one photon, that is energy equal to h and nu. And we can also write this equation as a hc upon lambda. So remember, photon is the amount of light energy which is being absorbed by organic molecules. Let us see basic thing. So if we consider basic theory behind the photochemical reaction, try to answer some of the things. Suppose in organic molecules there are different types of electrons are present. For example, sigma electrons. The sigma electrons are present in a compound which are bonded by means of only single bond. So what are these compound? Hydrocarbons. Let us say alkanes. Alkanes contains only sigma electrons, right? While pi electrons are present in the compounds such as alkenes, carbonyl compounds, imines. So these are the compounds. So these two electrons which are we are familiar. Sigma electrons in a single bonded compound, pi electrons in a double bonded compounds. And apart from that, there also contains one more type of electron which are non-bonded electrons. Non-bonded electrons are those electrons which are not taking part inside the bond formation reactions. So basically we used to call these non-bonded electrons as a lone pair of electrons, which you can observe in a compound such as alcohols, amines. In alcohols we know that oxygen is having two lone pair of electrons, while in amines here you can observe one lone pair of electron. So these are called as a non-bonded electron. I will repeat again. Bonded. What is the difference between bonded electrons and non-bonded electrons? Bonded electrons are those electrons which are taking part inside the bond formation. That bond may be, let us say, sigma bond or pi bond. And non-bonded electrons may be, let us say, these electrons which are not taking part in the bond formation. So these things must be clear. So these two are bonded electrons and lone pair of electrons must be non-bonded one. So let us see the basic theory behind the photochemical reaction. So as we know that whatever the organic molecule which is present at ground state is having some particular energy, so it is being bombarded with the source of light which may be in the range of 200 to 300 nanometer UV or visible light. So what will happen, whatever the molecule present in the ground state, because of absorbance of light energy, it will get excited to higher energy state, and we call this particular higher energy state is called excited state, where the molecule is promoted from ground state into excited state, right? This is a simple thing we already know. So what happens basically when a molecule get promoted from ground state into excited state? So whatever the electrons present in bonding orbital or non-bonded orbitals, they are excited to unoccupied anti-bonding orbitals. Okay, the electrons from bonding orbitals get promoted to anti-bonding orbitals. Here you can see these are the bonding orbitals. Here you can observe at the ground state. When they get excited, so they get converted into anti-bonding orbitals. Anti-bonding orbitals are unoccupied, which are empty, which are present. Just like a promotion of electrons from 2s orbital to 2p orbital. So this is called as excitation. We used to say in case of the hybridization of molecules. So here you can see one of the electron will be promoted from this to this. So this is a basic theory which takes place in case of the photochemical reaction. So what is that theory? Excitation. Basically we can say electronic excitations, in which excitation of electron takes place from bonding orbital to anti-bonding orbitals. So as we know that whenever the electrons present in the ground state, they may be, let us say, sigma or pi electrons, or non-bonded electrons are called as n electrons. So what will happen when the promotion of an electron takes place from bonding orbital to corresponding anti-bonding orbital? So what will happen at that time? The electron present in sigma orbital get promoted to sigma star. Sigma star is anti-bonding orbital. Where another phenomenon, in case of the pi electrons will get promoted to pi star. Pi star is the excited state, where electrons from bonding orbital get excited to anti-bonding orbital. Or in case of n means non-bonded or lone pair of electrons which are getting promoted from n to pi star. So remember electronic transitions from ground state to excited state. This transition may be sigma to sigma star, maybe pi to pi star, maybe n to pi star. So this is a basic theory which happens in case of the photochemical reactions, where electrons get promoted to excited state. Okay, so this is the basic things we have to remember. So let us see what are the different electronic excitation. This is a orbital diagram which has been shown in case of the molecule 1,3-butadiene. So let us see. Ground state, there are how many electrons? 1, 2, 3, 4. So what will happen once this particular molecule receives a photon energy h nu? So what will happen? One of the electron from here will get promoted to higher energy orbital. So this is at ground state, how many electrons are there? 4. In excited state, what will happen? One of the electron from here will promoted to anti-bonding orbitals, right here. Just like a promotion of electron from 2s to 2p orbital. Okay, so what you can observe? 1, 2, 3, 4. So 3 electrons are present in bonding orbital and 1 electron is present in anti-bonding orbital. Okay, so this is a simple phenomena you will observe. And we know that in case of the butadiene, there are pi electrons are present. So what will happen in that case? Pi to pi star transition will take place. The pi electrons will promoted to pi star from sigma 2 to sigma 3. So remember this thing, the electronic excitations. So basically what happens in organic molecules, the electrons in ground state are paired. Paired means in this particular form. Okay, pairing. Pairing means what? One electron with parallel spin and one electron with anti-parallel spin. Okay, so this is being called as a paired. Just like here you can see. So this is a paired. And right now what you can see, these two electrons becoming unpaired. Okay. So now when absorption of light of correct energy takes place, then one of the electron is excited from ground state to excited state. Okay. So this is a thing we have to remember in case of the excited state. So two electrons may not have spin, may not have same spin. I will repeat again. Whenever the excitations takes place from ground state where the electrons are paired, ground state में क्या होता है, electrons paired रहते हैं, one with parallel spin and one with anti parallel spin. और जब excitation होता है उसका, तो क्या होता है, एक इलेक्ट्रॉन बॉन्डिंग ऑर्बिटल से एंटी बॉन्डिंग ऑर्बिटल में जाता है. तब क्या हो सकता है, ये दोनों जो इलेक्ट्रॉन की जो स्पिन है ये सेम नहीं रह सकते. मतलब एक पैरेलल स्पिन, दूसरा एंटी पैरेलल स्पिन. और व्हाट इज अनदर पॉसिबिलिटी, वन विथ पैरेलल स्पिन एंड सेकंड आल्सो विथ पैरेलल स्पिन. सो दीज आर द थिंग्स विच वी ऑब्जर्व इन टर्म्स ऑफ द two electrons. Do you understand what is mean by spin? I will explain. Spin means what? Electrons rotate around the axis. So when you observe such type of electrons with parallel spin, we used to say this particular spin as a half plus half. I will explain. There are two possibilities are there. Whenever there is the electronic excitation takes place, they are of two types. One is singlet state and another is triplet state. First we will see. Concentrate. What will happen in ground state? We know that electrons are paired, one with parallel spin, another with anti-parallel spin. So what will happen once the excitation takes place, like this particular molecule absorbs light. So what will happen? These two electrons become unpaired. So it will promote it to anti-bonding orbital. So what will happen? These two electrons may have one with parallel spin, another with anti-parallel spin. यहाँ पे जैसे था वैसे ही होगा, सिर्फ क्या होगा, वन इलेक्ट्रॉन बॉन्डिंग ऑर्बिटल में रहेगा और सेकंड इलेक्ट्रॉन एंटी बॉन्डिंग ऑर्बिटल में रहेगा. सो इन दैट केस वी कैन से दैट पर्टिकुलर एक्साइटेशन इज ऑफ द टाइप सिंगलेट स्टेट, दैट इज डिनोटेड बाय S1. So we can say that particular transition is from S0 to S1, right? While in case of the triplet state, what will happen? Both the electrons present in bonding and anti-bonding orbital will have spin that is parallel. Okay? Here you can see upward arrow, downward arrow, upward arrow, upward arrow. So this particular transition is called as a triplet state. So remember there are two types of electronic excitation state takes place. One is singlet state, another is triplet state. Why it is called singlet state and triplet state, I will explain you. So what is mean by singlet state? A molecule in which electron spins remains paired. Paired means यहाँ पे जैसे paired रहता है parallel anti parallel, वैसे ही यहाँ पे रहेगा in excited state. So this particular state is called as a singlet state, that is S1. And in triplet state, the two electrons become unpaired. Unpaired means parallel anti-parallel था, तो unpaired में क्या होगा, parallel parallel हो जाएगा. Okay, here you can see in case of the triplet state means we can say they have the same spin, plus half plus half. यहाँ पे कैसा है, plus half minus half. So this is a thing you will observe in the triplet state. I hope so you will understand the concept of singlet state and triplet state. If we see which particular state is more stable, because triplet state is more stable as compared to singlet state. Why? Because in triplet state electrons are unpaired. Electrons क्या रहते उसमें? Unpaired रहते. So lesser inter-electronic repulsion will take place, because we know that repulsions are there with the parallel. So that will be lesser in case of the triplet state. So in singlet state electrons are paired and causing inter-electronic repulsions. They are having the repulsions and they are unstable. So this particular state is unstable and this particular state is stable because of there are less electronic repulsions. Now we are going to see the another term that is being called as a spin multiplicity. Basically, when electrons are paired, let us say plus half minus half. So at that time, what is the spin? Plus half minus half. Okay. One electron is having plus half, another electron is having minus half. That is okay. You already know this particular concept. So how to calculate the spin multiplicity? What is the formula to calculate the spin multiplicity? That is equal to 2s plus 1. Spin multiplicity is equal to 2s plus 1, where s is total spin of electron. Electron spin can be either plus half or minus half. Okay, so this particular spin multiplicity will help to understand electronic state, whether it is a singlet state or triplet state. So when you have spins which are paired just like this, so what will happen? In that case, one electron will have plus half, another will have minus half. So S, we need to calculate S first. S कैसे calculate करेंगे? एक इलेक्ट्रॉन का प्लस हाफ है, दूसरे इलेक्ट्रॉन का कैसा है? माइनस हाफ. इन केस ऑफ द पेयर जस्ट लाइक दिस. सो प्लस हाफ माइनस हाफ इज इक्वल टू 0. सो यहाँ पे s का वैल्यू क्या हो जाएगा? 0. सो 2 इंटू 0 इक्वल टू 0. सो प्लस 1 इक्वल टू 1. सो स्पिन मल्टीप्लिसिटी क्या आ गया? 1. किस केस में? स्पिन पेयर्ड में. सो this is called as a singlet state. So remember, when you have the spin multiplicity equal to 1, that particular state is called as a singlet state, right? Singlet state can be S0, S1 or S2, right? Remember, S0 means ground state, S1 means excited state, S2 also excited state. So remember, singlet state में क्या रहता है? स्पिन मल्टीप्लिसिटी 1 रहता है, इसके लिए उसको क्या बोलते हैं? सिंगलेट स्टेट. इन केस ऑफ द ट्रिपलेट स्टेट, व्हाट इज अनदर कंडीशन? बोथ द इलेक्ट्रॉन्स विल हैव पैरेलल स्पिन. मीन्स कैसे? यहाँ पे कैसे रहेगा? ये इलेक्ट्रॉन यहाँ पे ऐसे, वो दोनों का स्पिन क्या रहेगा? अपवर्ड. सो उस केस में क्या हो जाएगा? प्लस हाफ, इसका क्या आ जाएगा? प्लस हाफ, और इसका भी क्या आ जाएगा? माइनस हाफ. सो प्लस हाफ कितना हो गया? 1. सो s का वैल्यू कितना हो गया? 1. सो 2s प्लस 1, 2 1 प्लस 1 कितना आ गया आंसर? 3. सो दिस विल बी ट्रिपलेट स्टेट. सो ट्रिपलेट स्टेट कैन बी T0, T1 or T2. So this is a triplet state. So in short, what you have to remember, in case of the singlet state, spin multiplicity is 1. In case of the triplet state, spin multiplicity is 3. When you have the spin multiplicity 1, in that case the electrons are paired. When you have the spin multiplicity 3, in case you have unpaired electrons. Now we are going to see what are the allowed and forbidden transitions. Now you have understood what are the transitions. The transitions can be from the singlet to singlet or triplet to triplet. Okay, so allowed transition means what? Where you have such type of excitation, like from singlet to singlet, S0 to S1, this will be allowed, or triplet to triplet, that is allowed, from T0 to T1, that is allowed. And another is forbidden. Forbidden means what? Which is not being allowed. Okay, what are the forbidden transitions? Which involved in different multiplicity state. Different multiplicity state means what? From singlet to triplet or triplet to singlet. These are forbidden. Forbidden means which are not allowed. Okay, I hope so you have understood what is mean allowed. Allowed means in the same multiplicity, singlet to singlet, triplet to triplet, this is allowed. Forbidden means singlet to triplet or triplet to singlet, this is forbidden. So it's not like that forbidden transitions means these are impossible, वो हो ही नहीं सकते ऐसा नहीं है. But if you change the condition, that is also possible. Forbidden transition means S1 to T1 or T1 to S1, it is possible in case of the special condition. So that for that we have some rule, selection rule. So it is based upon the assumption that in that case, in case of the forbidden transition, the geometry of the molecules remain unchanged during geometry उसकी वही रहनी चाहिए. In that case also that is possible. S1 to T1 may also possible where there is a temporary change. So when your this forbidden transition, there is only temporary change is there. In that case also that particular transition is possible. Forbidden transition, that is S1 to T1, may also takes place when vibration level in S1 and T1 states have same energy. Means S1 and T1, if they have the same energy, in that case also that particular transition is possible. So that particular state is called as a crossover. Remember, forbidden transitions from S1 to T1 or T1 to S1 is possible when both these states have same energy. Generally we see that S1 to S, this is a different energy in case of T1 to, but this is a thing we have to remember. I will repeat again. Allowed transitions are those transitions which are taking place in the same multiplicity state, that is singlet to singlet. In case of the forbidden, singlet to triplet, these are not allowed. But it is not a case that these are impossible. They can also possible when they have the same geometry which is being taking place in the electronic excitation, or they have same energy. Go through this particular concepts. I hope so you will understand. This is a simple concept which you need to understood in case of the photochemical reaction. This is only one thing we have to remember. In case of the photochemical reaction, whatever the reactant present in the ground state get excited into higher energy level, that is excited state, and where the spin of electrons get altered. Based upon that, you can have either singlet state or you can have also triplet state. We will see in the next lecture. Thank you.